Sorry, there's your pictures. All right. I did get that clear screen for my face. Did I tell you about those that I bought? Then I did it first hour and nothing but a bunch of steam and spit was going on this and it looked disgusting. So it was a waste of $20. So anyway, you won't see that. I'm gonna have to, you're gonna have to deal with not seeing my mouth, that lack of communication, I think. But I think we all read lips. We don't realize it. So in the teaching aspect, I was very disappointed that we have to have these masks. Now, remember what we said about a difference of two squares? By the way, good foilers, say it. Oh my gosh, I forgot it was fifth hour. Good foilers are, say it. Good factors. Because first of all, we should understand, I got to make sure this microphone's always with me, that a times a equals a squared. This makes me infinitely sad, students that cannot figure out factoring and cannot figure out that it is the opposite of FOIL. Right? It really, 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 at this stage of the game, is problematic. And then understanding that this has to be b and b because of last for FOIL. B times b is b squared. But wait, something's wrong. That has a minus sign. That's because these have to be plus and minus or minus and plus. They must be opposite. Good foilers are good factors. If you don't know how to foil, you will not know how to factor, and this is going to be a rough year. Just being honest that we got to get on board with that and get it figured out and simplify it. Okay, and that's the case. And again, you could switch the plus and the minus. That is commutative, is what that's called. Switching those parentheses. Next, and Kathleen, you're still fine. We're going to get you later here. A cubed. Let's roll this over here because I think I can fit it. This is for sum and difference of two cubes. So I'm going to write that over here. And really what you can count this is as a formula. This is something you're just going to have to remember and memorize. Like later, the quadratic formula is going to come back, and you're going to be expected to have that memorized, but that's not right now. Okay, and then I'm going to shrink this down a little bit so I can use this space. And then, and again, with a formula, I'm just going to show you what it is, and you have to memorize it. Okay. So to factor this, you actually have two sets of parentheses. A binomial times a trinomial. Really make that obnoxiously large. Make the second one so you know that, oh, okay, I got more in the second set of parentheses. Okay, now we use A and B just as like a formula A kind of thing. So A cubed plus B cubed. The first set of parentheses is whatever the perfect cube units are for each of those terms. And hopefully you know your perfect cubes. Hopefully you're numerate. Hopefully you know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, right? Do we all know these things? 3 times 3 times 3. What's 4 cubed? 3, 2, 1, go. 64. 64 is a special number. It's both a square and a cube. What's 5 squared? 5 times 5 is 25. What's 5 quarters? 125 is a perfect cube. We got to know these things. We got to be numerate. That might be big. That might be big enough. I might only stick with those numbers. Anyone know 6 cubed? That's a big one. It's in the 200s. You know it? Oh, I thought you had a hand up. 6 cubed? Anyone? 2? Yeah, I said that. 2. 16. No one knows that one? Never heard of that one before? 216, 6 times 6 times 6. Might be if you have a calculator, like, wait, what's 216? Maybe it's 6 times 6. Oh, it is. Okay. And then that would be something that would fit here. Okay, now, here's where SOAP comes into play. Does anyone remember SOAP? Okay, SOAP on this. How many people remember doing sum or difference of cubes at all? Well, I think you're lying. I think you definitely did this because last hour said they did. All right, they have. And SOAP actually goes like this. Put it underneath here, S, O, and then AP at the end. Stuck together. And I'm going to tell you what S is used for. It's for the sign right here. So what do you think the word S stands for? Nope. Same. It stands for same. Maybe put that in here right now. I really think you should have done this last year. But you know what? It doesn't matter. I'm teaching it as brand new. It's a formula and it has to be memorized. So you just got to do it. So if that stands for same, what does the O stand for? Opposite. And then what do you think the AP stands for? No. Yes. I like it. But you know what it actually stands for? Always positive, which in the case that you just said is addition. Right? But we like the SOAP acronym because, I don't know, it's just something that sticks in. Okay, now listen. This is the good foilers, good factorers thing, but this isn't a foil, but it's like it. A times what equals A cubed? It's a very simple question. What's the answer? Okay, one more time. This is fifth hour. A times what equals A cubed? A squared. That's got to be A squared. This is where I go crazy. People just don't accept what I'm teaching, and to try to simplify this to make sure you understand your answer must make sense when you write it down. Okay? So that becomes A squared. So here's actually the pattern. Once you get this first set of parentheses, A cubed plus B cubed, first set is A plus B. This term is this one squared. That's exactly what happens. The next term is these two multiplied together. Now we're in a formula. Okay, and you're just going to have this memorized. This second term is A times B, whatever those two terms may be. Oh, by the way, opposite means minus in between there. And then the last term is this last term in the binomial squared again. I'm kind of writing, it's kind of hard to write right now. And there's the factorization of that sum of two cubes, and I can prove it. What's A times A squared? We already checked that. What does that become? A cubed. That's in the question. This should multiply and be the question. What's B times B squared? B cubed. I got these two components. Everything else must what then? Cancel. And then watch. This is A squared B negative. Sorry. Negative A squared B. And this is positive A squared B. What happens? They cancel. This is AB squared. This is negative AB squared. What happens to those two? They cancel. So I've just proved that when I multiply this answer, I get the question. That means this is the correct factorization of that question. And that's the idea of good foilers or good factorers. I infinitely get sad when people don't even come close to checking their answer at the end. The biggest thing that goes wrong is this. This isn't even close to being that last term in the question. Not even close. And I'm just speaking out loud about what I've seen in the past for so many years. And then guess what? This is crazy. This is why I put this up here. For squares, I should have put A and B. There is no sum of two squares. All right, that factors. But for cubes, there's both a sum and a difference of two cubes factorization. What's in between these two, though? What's in between those two right now? Same. So what's in between those two? A plus or a minus? Well, this is a minus. So what's the same as that? Minus. Okay, that's the difference between the two factorizations. And then it's still A squared, A times B, B squared, as far as the format of factoring this. And then what's the opposite of minus? Plus, and then always positive. So look at the difference. Look at the minor difference between the two. And then look at what happens with good foilers, good factors. A times A squared, yes. Oh, negative B times positive B squared, negative B cubed. Guess what happens to everything else? And I'm not going to show you. What happens to everything else? Cancels. Let's move on. So I think I did this, right? Didn't I do 8, 9, and 10? Correct? What? I just did 8? Well, then let's do 9. Hey, what is that? It's a difference. Is it a difference of squares or cubes? Actually, it's time for Kathleen. Kathleen, is that a difference of squares or cubes? That's interesting because 64 is both. a square, and a cube. What's 25? A square or a cube? It's a square. Okay, so then this is this factorization, and we need to get there pretty quick. Kathleen, what's the perfect square of 64? What times what equals 64? So it's 8 here and 8 here, because that's first the FOIL. And then what's the perfect square of 25y squared? And then what do I put in between both each, like first one and second one? What signs? Did you say it? I can't hear you. Plus and minus. You got it. Another victim of the these things on our face that it's hard to hear as well. And it's true, because good FOILers are good factorers. I can't do this enough for you to get it. 8 times 8, 64. 5y and negative 5y is negative 25y squared. Everyone, what happens to the middle term for O and I? What happens? Tell me. It cancels for everyone else that needs to see it. So the answer that you have there must make sense comparative to what we have as the question. Next one. All right, let's get a student. Good job, Kathleen. I know you hated that, but don't you feel alive, Kathleen? I don't know if she answered or not. Jennifer, you're next. You ready? Sorry, I should have had Kathleen go through this. You're always supposed to check for a GCF. She didn't have one, so we got lucky. Do you have a GCF? What do you have? Okay, you pull that out, and then I'll do that for you. End of the fourth minus 25 is what ends up happening. What do you have now, Jennifer? Yeah, it's the square thing. You got it. Then can you just tell me what the answer is then, maybe? Gotcha. You say plus 5? Got it. The perfect square of n to the fourth is n squared. So she is spot on. Or good FOILers, good factors. N squared times n squared is n to the fourth, and then 5 times negative 5. Middle term cancels. I really don't understand people that cannot FOIL and actually check that. It's going to be rough. Oh, no. Okay, good. Maybe we'll get everyone in this smaller class. This is cool. And if your number comes up again, guess what? You're going again. Oh, man, that's why, my number got picked. I can relax the rest of the way. Oh, she's absent. 16. You're 17. Did you have a question? No, I thought you're 4, 8, 12. She's actually counts as 16. So who went? Hey, Mitchell, we can't get out of the first row. Nice. Mitchell, you ready? Hey, what do you have here? Go. Let's start it. I'll tell you. Binomial times trinomial. Let's make it obnoxiously large there to make sure we know the difference. What's the first set of parentheses? And then what's the next set? Yep. Nice. Y2K. Oh, you guys weren't even born for Y. Did you ever hear of Y2K? Anyone? Anyone ever hear of Y2K? He said Y2. It just reminded me of that. Let's move on. The world was supposed to shut down and this planes were going to fall out of the sky because they were computerized. There's another, terror moment for humans. But go ahead. Oh, plus 2 squared. Hey, let's put plus 2 down, though. Look, what's 2 times 2? 4. So it doesn't match. This is my point. Oh, okay. No, I erase. And that's what's got to happen. And you already caught yourself. What is it actually? And then you, all right. And then that's what I told you. This is the number one thing that goes wrong with sum of or difference of cubes. That last is like all jacked up. All right. And actually, many times it's first. So minimally check those, and then you're probably okay. But if you want to keep going and make sure you got the signs in the right spot, that's pretty smart as well. But usually in that factorization, that's the problem. Was there any work to be done? This is it. You're done. Factoring sometimes is just, you just do it. Question? For the second one, why is it positive but then negative? This is SOAP, right? So same and then opposite of what you started with, which is the plus sign. So opposite plus is minus. Yes?
Can you go over like how we get like the y plus 8 again from like the things in parentheses?
All I could say is it's a formula, and it works. I don't know what else I can tell you as far as like how to analyze your question there. This is just what it is. It's like you know what the quadratic formula is. You just got to know it. You just got to know what the parts are and where they go. And then at the end it works. What's y times y squared? Y cubed. What's 2 times 4? 8. Those always make the first and the last term. Everything else falls out, and it just happens. All right, and sometimes that has to be the answer, because that is the answer. I mean, there's no other way of approaching it. I wish I had better questions that were a little bit more involved, like with some more variables. Maybe we'll hit that later. But I think probably right now we're okay with this staying small, because this is kind of a small one too. Who's student number 9? 489. It looks like Adam to me, right? All right, you ready? Oh, I got to move that. Okay, Adam. Hey, and you get to hear your name, not your last name, so it's not illegal on YouTube. But then you can go home and say, "Hey, that was me." Anyway, okay. So again, I wish I had the thing. I'm smiling right now, but small and big, just to make sure it's binomial, trinomial. What's the first set of parentheses? Do you think? Correct. Now this is how you should do it. You ready? I'll help you out again for everyone else. Here's the pattern. This squared, these two multiply together, this squared. And that's what it is. So go ahead, fill that out with the right signs as well. Which is 1. Good. 1 squared. Oh, same, opposite, always positive. So what goes there? Plus. And then what's the middle term? 1n or just n? You can put 1, that's fine. Always positive. And then here's your check. What's negative n times positive n squared? Minus, though, right? So you were about to put a minus sign there. A negative times a negative is a positive, and wouldn't match. That wouldn't match. Check! I'm yelling at other students of the past. Did I do this one? Okay, I won't force. This is where your pattern recognition needs to come in. This is not at all what we just did. Student number 7, which is Ella. You back there, Ella? Okay, this is a trinomial now. This is your pattern recognition of how I need to do this one. Do you remember what we do on this one? Yep, we're just ready to get an answer. You got the right answer. I'm going to help everyone else by showing what you got out of that. Because of FOIL, you just have to analyze what multiplies the 14, and then those same two numbers add to be 9. Good FOILers? Good factors. N squared, 14, right? And then 2n and 7n is 9n. That's what I mean about that. If you're just going to go ahead and do the parentheses, which I demand, just check it at the end. All right? And be a good FOILer and FOIL real fast. You can't FOIL, this is going to be a rough year. That is a freshman year concept, being able to FOIL and multiply binomials. All right, boom, boom. All right, now here we got the big star. Put a star by this one. I will be honest, last hour, a student just did the parentheses, and they guessed and checked. And really, this is what I would love everyone to be able to do. I would love them to be able to stick these parentheses here and start guessing and checking. Like, for instance, what equals 14y squared? I'll answer the question. It's either 1y and 14y, or it's 7y and 2y. Correct? Right? And then what they do is they put those in there, and then they start foiling to check the unfoil. Guess and check. This is not bad. What equals negative 5? What times what equals negative 5? 1 and 5, both of them, one of them being negative, right? So it's either negative 1 and 5 or negative 5 and 1. And then they start a combination of trying to get it done. And one girl got it done in like 10 seconds. Does anyone think they have the answer? Just raise your hand if you think you've unfoiled. So we already got that. And I want that. I don't need to see what I'm going to show next. Got it? It's definitely where I'd love everyone to be able to go. Because good foilers are, say it! Good factors. This is the whole idea, and I don't think people do that. They become robots and look at the patterns that I describe and then just try to follow them and don't even analyze their answer. That's what's got to go out the door. We got to start thinking. But I will show the pattern that hopefully your math teacher, because the math department at Lockport made a commitment to this way, because it actually does reverse foiling. All right, and it looks like the foil steps in reverse. M is not -5. That is not the M number. This jacks up everything, that 14 in front of the y squared. Does anyone know what the M number actually is that remembers this from last year? It's -70. M is 14 times -5, which is -70. And then A is still the middle term, which is -33. Next thing is, what are the two numbers that multiply to -70? Same two numbers add to be -33. He's already got it, and I see a couple other hands, but go ahead. Okay, now here's where I get sad. I will have some people write that then. They will say y minus 35, y plus 2 is the answer, and they'll move on. Good googly moogly. What is y times y? Not 14y squared. What are you doing? Good foilers are what? Your answer should foil to be the question. What are we doing? And then what's -35 times 2? Is that -5? Again, this is somebody that has not, after me saying this 38,000 times, committed to the good foiler is a good factor. I yelled so much I think I broke my pen. Oh no. Oh God, that's a big yawn. Everyone okay over here? He just sucked all the oxygen from the room. What is happening? Can I write with my finger maybe? Let's just start doing that. No. This is great. Now what do I do? Oh, you know what? It just unscrewed. Maybe that happened. Oh, wow. That's wild. So my pen unscrewed a little bit and then it stopped working. Let's get that bad math out of here. Here's what you do. Do you remember this? You take 14y squared and then you split up -33y into those magic numbers. This is equal to -33y. So therefore, we've not changed anything. And then -5. So this is equivalent to the previous step. So we are okay. All right. And then the next thing. Did I call on anyone yet? Who is student number 7? No, you went, Ella, right? Okay, so student number 21. Nice. We're getting over here. Is that the last student in the class? Or did I wait? So I had 4. Oh, because someone left. Did I count her or not? Did I call you student number 8 and you were 7? 4, 8, 12, 34, 36, 17, 18, 19, 20, 20. I don't know what I'm doing. That's you. For some reason, I'm counting 22 in this sheet. I'm freaking out, man. All right, Matt. Now what? I have 4 terms. How do you factor with 4 terms? There's only one way. Now I made it into 4 terms. 4-term factoring, what is the thing? I'll help you. It starts with a G. Don't say GCF. The other one that starts with a G. GR. So you always get help. GRO. Okay, one more letter now. Hope you get it. GROU. What? Grouping. And what we do is we group this and group that. And then we take a GCF out. So grouping does require GCF factoring next. So look at the first 2 parentheses, or the first parenthesis. What can I pull out of that? Not only a Y, there's something else. What does 14 and 35 have in common as a factor? 7y. And then what are you left with when you undistribute that 7y? 7y times what equals 14y squared? 2 what? Don't forget about the y. And then 7 times what equals 35? The y is already out. But it's minus, right? Now I will help Matt. Matt, right? Matt? I'm just short-term memory guy. You should probably take out a 1 because just so you see it. But 2y minus 5 does not have a common factor. But take out a 1 so you see it for your final answer. Now, the reason I highlighted that is this is the only way grouping works. And the fact that you got the correct magic numbers that multiply and add, this is why these two parentheses are exactly equal. And then listen one more time. I know a lot of students don't get this and they just write the final answer, but really this is a GCF binomial. If this was 7yq plus 1q, everyone would understand that I could pull out a q. They have a hard time understanding that a binomial can be a greatest common factor. And when I pull that out, that's like these are gone now, and I'm left with a 7y plus 1. And that's why I put the plus 1 there, so you don't lose that. Good foilers, anyone? And then who said they did it before without doing all that? Isn't that what you got for an answer? I want you to do that and not really have to see this. All right? But anyway, good foilers, good factors. What's 2y times 7y, everyone? Look. And then let's just look at the end. What's negative 5 times 1? Right? And then the middle term, 2y and negative 35y. Ah, that's why this works, and that's why it's all solid. Are you okay? Oh, it just looked like you're like, whew. Okay. I'm having fun. Oh, hey! Nice. Is that only the second time, Mitchell, or third? Second. Okay. Well, I think one happened last hour twice too. That's what I'm getting. What's the only way that you could directly factor this one right now? Oh, okay, that's a good call. But is there one? No. I mean, I got threes here, but no threes here. I got some ends, but no end in that one. Bummer. 4 terms, by the way. There's only one thing. Did I write this up here? Let's go back up to the words. Yeah, right here. Do you see that? Okay, so how are we going to factor that? There you go. So you know what you do? You just group the first two and give it a try, and group the second two. In the first set of parentheses, what's the GCF? You are correct. You undistribute that, and what are you left with? And then, you know what? It's the same thing. I'm sorry that I have 2 examples like this in a row, but I guess it's good. You want to pull out a 1 just so you see that, so you write your final answer correctly. All right, and then yet again, this is a GCF binomial. You pull that out, lost my minus sign there, and you're left with end of the fourth plus 1. Good foilers, good factors. You should check the foil real quick, but I'm going to move on. So that encapsulates probably all the factoring you're going to do. And I know I said those 2 over there, great job on just getting an answer for this, but this is the fallback. And I do want to say this. Hey, when you foil this, isn't this exactly, except for this step, actually this is the way it's showing it as distribution, but if you foil this, this would be the next step, and then you combine like terms. So that's why this looks great going this way for factoring. That's the whole point I've been trying to hammer in your head these last 2 days. Oh, here we go. Are you ready for this? Bum, 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 bum. Now we're going to this. You feel free to read is up at the top. I'll just talk you through it. Okay, boom shakalaka. This is going to be more of the same. 18, 19, 20, 21. 18's in the back there, Samantha, right? Samantha, I got a cryptic question for you over here. And I know when I do these things, sometimes students like it. They don't like it, and I don't care. Because actually, this is exactly correct, what I'm going to show you next. What students do wrong here. Samantha, you're going to think this is wild, but does 6 over 5 reduce, yes or no? Just answer my question. No. But you know what? Isn't 6 5 plus 1? Isn't it? True or false? Is that true? So now I made 6 a binomial. Huh? That. Okay? So 5 plus 1 over 5. Oh, you know what? Now I can cancel this 5 with this 5. This becomes 1 over 1, and 1 plus 1 is 2, and 2 over 1 equals 6 over 5. I love everyone writing this down. True or false, what I just did there? Or let me just ask you this. Does 6 over 5 equal 2? Yes or no? No, then obviously something's wrong, right? And what is wrong is when you take part of a binomial and cancel it with something else on the bottom. This is invalid bad math. Because I'll tell you right now, this is what I'm going to get a ton of people doing this year. And it happens every year. And I do the 6/5 thing, and it still happens. And all I can keep doing is keep trying. I get this all the time. Oh, okay, that's 1, and then this is n. And that is a 6/5 equals 2 error because variables are just numbers. They're just replacing numbers. They are numbers, and they follow the rules of numbers. And this is bad, so what I just did over there is really bad. So don't ever do it, is what I'm going to say there. Right? But we'll see. I can only keep trying. And when we get into fractions, boy, this is when the Calc students, things just start going crazy. All right, so back to Samantha. Here's what you actually do. You take this and you factor. What can I do with that bottom, Samantha, to factor? First thing you should always look for is a GCF. Is there one? In the bottom. Do they have something in common? What do they have in common? At least a what that I can undistribute. Yeah, you take an n out. What's left over when I undistribute an n? So you undistribute this, or what times what equals n squared. That's what goes here. And then what times what, what does this become? This times what equals 2n. What do I need here to make that true? Just a 2. And now this is free to be cancelable. Right? This is a separate factor now through multiplication. So the next thing I will do is cancel that. And the final answer is n squared over n minus 2. Samantha, should I cancel these n's? Should I do this? Yes or no? 6/5 doesn't equal 2, so no. Right? That's the whole point why I said that. Okay, and I know they said this up here. I think they say cancel when dividing, multiply by the reciprocal. No, they don't even actually talk about that, so I'm going to leave it alone. I did say it in the other hour. About restrictions in the denominator and all that stuff, but we won't worry about that for right now. Who's lucky number 13? 4, 8, 12, 13. Scott, up in the front here. All right, Scott, let's take the numerator first on this one. You got 4 terms in the numerator. What's the only way we could factor that? Okay, you didn't answer my question, though. By what way? I think, I know what you meant. Did you say it? Sorry. Grouping. Sorry, I couldn't hear you. All right, my bad. It's okay. All right. And then you take out a y squared. What's left over when you take a y squared out? Y plus 2, right? And then how about the second one? Notice what I did. I put plus a negative there. What should I take out of that set of parentheses? And I should have that plus sign in here. And then what do I take out? What kind of 3? There you go. Because you know what? For this to work, a -3 taken out from -3y makes that positive, and then -6 becomes positive. For this to work, these need to be exactly the same. If you only took out a 3, you'd still have the negatives in there. The only way grouping works. You know what? I'm going to keep going with that and get that numerator done, and then I'll ask somebody else, unless your number comes up again. That's the glory and power of that calculator. Right, Mitchell? You already went twice. Oh, nice. Jake? Jake, that's 2 for you, isn't it? Jake, what do we do on the bottom of this now that we got the top done? What kind of factoring would happen there? This also tells you where we're at as well, like as far as understanding and just checking the clock, 55. So we're factoring the bottom. 2 terms. It's not a sum of cubes because that's not a cube. There's no difference of squares. What do we always look for first? What do we always look for first? Jake, you're up. What do you always look for? Here, I'll go back up to the words. Oh, I can't. Those are the other notes. You always look for what? We're at an impasse here. Boom. No, that's not right. Where's it at? Oh my goodness. It's taking forever to. Boom. What do we always look for first? It's the top line. There you go. Greatest common factor. Let's go back to these notes. What is the greatest common factor of y cubed plus 2y squared? Ooh, y what? Yeah, too much. And then when you take out a y squared, what's left over? There you go. And then just think about distribution. Just check yourself before you wreck yourself. Ooh, that's the first time I said that this year. Make sure you redistribute that to think about if you're right. And then who cancels, everybody? This big fat y plus 2, since they are exactly the same binomial. Then and locked in parentheses. And then, God, I don't know why I'm sorry. Jake, y squared minus 3 over y squared. Should I cancel the y squared, yes or no? Thank the maker, because if there is one in the public school, sorry for even saying that. It's just a line from C3PO, so let's not all get offended. You can. It's a 6 over 5 equals 2 error if you do that. So circle that up, and that sucker is done. Let's see what we got over here. Yeah, I guess it's important to kind of cover this because there was a little wrinkle in this one. Okay, and I'll make this one go fast with student number 21. Boy, this calculator is loving repeats. Matthew, I should try to remember these names. I'm going to write this down. Nothing to do. Sorry, that's an N. Wait a minute. Matthew, what do you know about these two? Aren't they awfully close? What's 3 minus 2? Just answer that question. What's 2 minus 3? So, opposite when you switch. Or what can I factor out of this so it is exactly turning into an n minus 1? What can I factor out of 1 minus n so it turns into n minus 1? Nope. A negative. It's almost done. A negative. You got it. You got it. You take out a negative 1, and actually I'm going to put it. Okay, I'm going to put this in parentheses and then hit times. And then I'm going to put a negative 1. It's kind of hard to write a negative 1 in the middle of a set of binomials. Oh, no. Greatest ringtone ever, isn't it, everyone? Greatest ringtone ever. My phone went off. It was a one of those jerk callers, trying to steal my money. You know what those are, right? Those, the random scammer number, yes. Okay, and then, so this becomes n minus 1. That phone call threw me off. And then one more time, and then who are we dealing with? Oh my gosh, Matthew, this is my brain. Matthew, what's n squared minus 9? I'll give you a hint. It's parenthesis times parenthesis. It's one of those quick factors. And then what else? That's the difference of 2 squares. Check yourself before you wreck yourself. Right? That foils and ends up being n squared minus 9. And then now it's time to go crazy, man. I mean, this is the fun part. You're gone. And then all I'm left with is negative 1 over n minus 3. Oh, so not too bad. I was going to skip that one except for the n minus 1, 1 minus n thing. Look for factors that are opposites of each other. That's why I asked them the 3 minus 2, 2 minus 3 thing. They're opposites. That's why a negative 1 ends up being left over. Okay, still going. Wait, there's more. It's like the infomercial from, yeah. Oh, is that Gabriella, who's not here, right? Oh, sorry, Gabriella. Hey, if you're watching this video at home, your number would have been called and you would have known. Ella, didn't you already go? Too bad. All right, here we go. Isn't that mean? Oh, you're like, I heard that. You're going to hurt your tongue when you do that. Hey, what do you do with that one? It's take out 1y. And then 14y, nothing. And then what do you know about division? Oh, I'm going to turn it into multiplication, but what do I have to do? There you go. The old flipperoo. This is grade school rules. There is no, like, I don't get it on this. You either know it or you don't. There's a lot of that. And there's a lot of stuff that I expect you to know as we come in here. Right? And there's nothing to factor after that. All right, now this is what I did last hour. You got to be careful with cross slash and stuff and everything. So I might reorganize. Y squared times y is y to the third. And then that y minus 3. It would be, you can cancel. I'm just giving you like probably the most successful thing you should do, just to organize your thoughts. And then 2 times 14, I might leave it, because sometimes making the numbers large and then trying to, make them small again, it's better to just leave them as, and then see if anything cancels. And then n and then y squared. And then, sorry, Ella, does 3 go into 2 or 14? Yes or no? Nope. So it is going to be 3 over 28. And then what else cancels? What cancels then, actually, now that we got... Okay, so let's take the y's. Where are there more y's? Top or bottom? How many? 1. So you have a 3y on top. What would happen is this would cancel with this, and there'd be a y left over. And I guess that's it. Y minus 3 is still up on the top. And then I already did 2 times 4, which is 28. Don't lose that n. That's kind of a messy one. The final answer isn't all that great, but that's what it is. At least something canceled. Best thing to do is to kind of organize your thoughts on that one. All right? More of the same, just we're trying to get little different things. Division. Ooh, I almost killed that. Student number 6. Darn, that's an absence. We'll do this one real quick, but I got to get another student. Oh, I love the student thing. Don't you feel alive when you get picked? Ooh, Carolina. Nice. Now you get to go home and say, hey, that was me in class today. Hey, what's this? What operation is that? It is division. So here we're going to go. 2x squared, but I'm going to make you do something here. X minus 3 squared is just x minus 3 times x minus 3. Maybe that'd be helpful, or you can leave it as squared. Just know you have 2 of those factors. And then I'm going to make you do this. Times, not divide. So dividing by this, look at my fingers. Dividing by this, because that's what this means, going in this way, means timesing by the flip of that fraction. So this x minus 3 does go on the top. Oh, you actually don't have a bad problem at all. And 8xy. Ooh, I'm putting the pressure on you. Okay, 2 and the 8. What about the numbers? 2 over 8 is what? So how many times does 2 go into 8? Ooh. 2 times what is 8? 2 times...
I was thinking about 2 times 4 is 8.
There you go. So it's 1 over 4. And then an x minus 3 cancels, right? Let's get rid of that. Okay, and then let's look at just the individual x's. Where are there more x's, top or bottom? How many? By 1. So I do it that way, or fine, you can do this and then write an x. It's the same thing. I'm getting my final answer combined. Then what happens to y over y? They completely cancel and they're gone. So then, don't lose that x minus 3 on the bottom. And of course, we know that x minus 3, that x cannot cancel with that x. 6 over 5 equals 2 error. Keep your stuff structured, all right? And then make sure you know what's going on from there. Oh, man. All right, here we go. What time is it right now? 52. Hey, Carolina. All right, so how does this factor? This is awesome. Ooh.
Okay. Oh, wait. No. You just find the MA.
Correct. Nice. Recognition that it's a trinomial. So this is going to be parenthesis times parenthesis, simple MA.
So, -5 and -2.
So you know what that means? Because of time, I'm going to shove those in there real quick. She said -5 and -2. That means y minus 5, y minus 2, right? And you were going to get to that, but we're speeding it up. All right, next one. Oh, I don't know if I have time to get students here. Hey, student number 1, nice. Mitchell, he thought he was all done over there. What's this one? What do we do with this one? Hey, what is it? Nice. Don't you feel alive over there, man? Oh. Times 32y squared. I shouldn't have to explain that anymore. Dividing means flip, multiply, and then oh no. And I'll take this because of time. This one you should not do 4 steps. What equals 3y squared? I have no time for you to answer that. Everyone in this room should know at this point for the approach of factoring, should know that I only have one choice. It has to be 3y times 1y. That's what should be in the parentheses. Don't you agree? Yes, Mr. Samuelus. And then now it's what is equal to -8. This is the trial and error, and it's put in numbers, FOIL. If it's wrong, erase and try again. But I feel good about 2 times 4. All right, and then I'm probably purposely going to get this wrong. Let's say like 2 times 4 here, and I put a minus sign there, and I put a plus sign here. Why does that do plus minus? Because it's a -8 as a product. This is how he does the factoring. But what's 3 times 4? Y? -12y and 2y. Does that equal the middle term? Yes or no? So guess what I do? I swap it or switch it. And then this might be 4, and this might be 2. Let me think about it real quick. That is a winner. Winner, winner, chicken dinner. -6y and 4y. Yes, that's the middle term. And I know I have -8, and I know I have 3y squared. That is the crux of factoring. All right, and then you start canceling stuff as you walk out the door. Okay, so the homework is in the calendar. I'll go to that real quick. Yeah, your pictures. You can sue me. All right, and there it is right there. It's the same thing that you have, but those numbers are what we should really try to give a whirl at. All righty then. Oh, as I say, I thought it was